Hello everyone. Today I'm going to discuss electric charges, forces, basically electrostatic forces, fields, electric potential energy, and electric potential. Let's start with electric charges. Electric charge is a basic property of matter. Basically, for electric charge, a matter experience a particular force, either a attractive or repulsive force, due to bring another charge particle close to it. Okay, now the basically classification of electric charge, there are two types of electric charge. One is positive, another is negative. And basically the value of charges, which is basically uh, initially absolute value, which is 1.6 into 10 to the power minus 19 coulombs. So the unit of the charge is coulombs, and the smallest unit of the charge is 1.6 into 10 to the power minus 19 coulomb, which is basically the charge of a proton. And if you consider negative sign, this is considered the charge of a electron. Okay, so basically charge of an electron or charge of a proton, the magnitude is the lowest amount of charge, and according to the particular law, charge can be integral multiple of this smallest amount charge, say 2e, 3e, 5e. Here e represent 1.6 into 10 to the power minus 19 coulomb. Okay, so the 2.5e or 3.5e is not possible. Okay, then in case of forces, there is a force between two charged particles. So two types of forces, one is repulsive force, another is attractive force. Like signed charges repel each other, unlike signed charges attract each other. And for isolated system, the net charge of the system remains constant. So if there is no external charges considered in case of a closed system, then the total charge of the system will remain constant, which is called conservation of charge. Okay, now two basic types of materials. So one is conductors, another is insulators. Another materials is possible, which is called semiconductor, but we are interested in conductors and insulators. Materials such as metals that allow the free movement of charges is called conductors. So basically conductors are the source of free electrons or free charges, either electron or protons, basically, because charge represents electron or proton, either positive charge or negative charge. Basically conductors are the source of basically free electrons or protons. And in case of insulators, there is no free electrons or protons, there is no free charges. So materials such as rubber and glass that don't allow the free movement of charges are called insulators. Now in Coulomb's law, so Coulomb's law is basically about the force between two charges. Okay, by using this Coulomb's law, you can easily calculate the amount of force between two charges. Coulomb's law found that the electric force between two charges, which is also called electrostatic force between two charges, basically two charged objects, is proportional to the product of the charges on the objects and inversely proportional to the separation of the objects squares. So basically, if you consider, if you consider two charged particles, okay, Q1 and Q2, they are separated at a distance r. Then according to the Coulomb's law, the force, electrostatic force between these two charges, either attractive or repulsive, F, is proportional to Q1 and Q2. This is the multiplication of charges, and inversely proportional to the square of the distances. So the distance between Q1 and Q2 is R. So F is inversely proportional to R square. So F is proportional to 1 by R square. If we combine these two, then there will be a particular formula which is F equal to K Q1 Q2 divided by R square. So here K represent the constant which is equal to 9 into 10 to the power 9 or 1 by 4 pi epsilon naught. So basically formula is F, the force between two charges, so separated at a distance R, is F equal to 9 into 10 to the power 9 Q1 Q2 divided by R square. By using this formula, we can find out the magnitude of the forces because the force is a vector quantity. Now, electrostatic force, here 2.5 kg spheres are placed 25 centimeter apart. Each sphere has a charge of 100 microcoulomb, and of them positive and the other negative. So two charged particles, one is positively charged particles and another is negatively charged particle, equal amount mass and equal amount charges. They are separated at a distance 25 centimeter. Now calculate the electrostatic force between them and compare it to their weight. So we can easily calculate the weight because weight is just multiplication of mass with acceleration due to gravity, mg. Then electrostatic force, in case of electrostatic force, we have to use Coulomb's law. According to Coulomb's law, F is equal to K Q1 Q2 divided by R square. So here K is 9 into 10 to the power 9 Newton meter square per Coulomb square, which is constant basically. And Q1 and Q2 are given 100 microcoulomb, which is equal to 100 into 10 to the power minus 6 coulomb, okay, or 10 to the power minus 4 coulomb. Then R equal to 25 centimeter, which is equal to 0.25 meter. So we have to use SI unit. The SI unit of the charges are coulomb and SI unit of the distance is meter. Then the electrostatic force between these two charges, 9 into 10 to the power 9 into 10 to the power minus 4 into 10 to the power minus 4 divided by 0.25 square, which is equal to 1440 Newton. So the thing is that here two charged particles, they are positive and negative. So one is positively charged, another is negatively charged. In this case, we consider only magnitude because we are interested in the magnitude, the electrostatic force between two charged particles, the amount of forces, not the direction. Okay, so that's why we have used 10 to the power minus 4 and 10 to the power minus 4, both case positive sign. Okay. Then in case of weight, F weight is equal to mg, which is equal to 0.5 into 9.8, which is equal to 4.9 Newton. So the electrostatic force is very large compared with the weight here. Okay. And the thing is that you have to consider only magnitude if you try to find out the force between two charges. So you have to consider the magnitude of the charges, not the sign. Okay.